to verify it. Verify is another word for prove. To prove that these two functions are inverses, you can do the composite. Hopefully you can do a composite. And if the answer is x, and you do the composite the other way around, and the answer is x, if both of those are true, then you have a composite. So we need to start out with two functions. Two x plus 4 and g of x equals 1/2 x minus 2. Those are my two functions, and I am going to verify, I'm going to prove that they either are or not inverses. So I'm going to do f. I'm going to start with the function called f. And in place of the x, I'm going to put in g of x. And I'm going to distribute. Two times a half, half of 2 would just be 1x. 2 times 2 would be minus 4 plus 4. What's that equal to? That's what I want it to be equal to. But I'm not finished, because what does this say? And I also have to prove g, start with the function called g, and in place of the x, substitute in the function called f of x. Distribute. Half of 2 would be just 1x. Half of 4 would be 2. And then that's minus 2. What's going to happen to my 2's? This one came out to be x. This composite came out to be x. Therefore, I know that f of x and g of x are inverses. This proves it. Not if they equal the same thing. I'm glad you said that, because it's not that they equal the same thing. They have to equal x. If this one equaled 2x and that one equaled 2x, that still wouldn't prove inverses. They have to equal x. They both have to be the same thing, but they both have to also be the same thing, that is x. Okay. The next example. If f of x equals 3x minus 9, and g of x equals negative 3x plus 9, are those going to be inverses? F 3x minus 9. In place of this x, I'm going to put this function. Distribute the 3. 3 times 3. 3 times 9. Is that going to equal x? I don't really care what it's equal to. I know it is not going to be equal to x. I don't have to do the other composite because I know right now these are not inverse functions, because there's no way that's going to reduce to x. If I did the composite the other way around, it's not going to equal to x either, because they're not inverses. Okay, do you understand why I don't have to do both parts this time? Do you understand why I had to do both parts on this one, but not on that one? Once I know it's not an inverse, I don't have to do the other one to prove it's not an inverse. I know it's not. So let's try another one. F of x is 4x plus 3. G of x is 1/4 x minus 3. To prove it's an inverse, I do a composite. I start with f of x, and in place of the x, I substitute the other function. So 4 times 1/4, the 4 and the 1/4 cancel each other out. That's just x. 4 times 3 would be 12, and plus 3. Is that going to equal x? This is not equal to x. Therefore, I don't have to do the second one. These are not inverse functions. Example number 4. F of x equals 3x plus 6. G of x equals 1/3 x minus 2. To prove that they are composites, to prove they're an inverse, I use composites. And so I'm going to do a composite starting with f, and in place of x, I'm going to substitute the function called g of x. I'm going to distribute the 3. 3 times 1/3. 3 times 2. What happens to my 6's? Am I finished? Can I make a conclusion that this is an inverse? Not yet. If I get x there, then I have to do the second part. And I have to do the composite the other way around, starting with g on the outside and substituting f of x and then combine like terms, or distribute the 3 and work it out. I'm not saying it right. 1/3 times 3 cancels that out. 3 will go into 6 2 times. 1/3 of 6 is 2. What's going to happen to my 2's? What do I have here? What do I have here? if I do the composite, f of g of x and g of f of x, both ways, and both times I come out with an answer x, I can make the conclusion these two functions are inverse functions. That's it.